Hi everyone, this is Mr. West. Today we're doing a reading box plot, Khan Academy. So let's go ahead and get started. Find the interquartile range of the data in the box plot below. So let's just kind of break down what a box plot is. It's a really good way to represent data. So in this case, we have massive farmer phase pumpkins. Okay, Halloween's coming up, so everyone's on this pumpkin craze. But here is the data that represents the mass of the pumpkins, how heavy they are. So, what does this mean? Well, these are the kilograms. So you can see that there's a dot here at 10 kilograms, right here, 10 kg. And then there's another one at 4.5 kg. This one is the minimum. This is the smallest amount that there's an actual data plot for. Okay, so there's a pumpkin that weighs 4.5, and we know it's the smallest because there's nothing to the left of it. Okay, it's the smallest pumpkin in the patch. And then we know that this one's the biggest, the 10 kilogram one, because there's nothing to the right of it. Okay, now, this part is probably the trickiest part, but it's not too bad. First, we have this little box here. That's why it's called a box plot, or box and whisker, where these would be the whiskers. Okay, but this box is a lot of good stuff going on here. This box, how many times can I say that, represents this with this line, the median. Okay, so that's the middle of the data. And then we have two things that I'm going to change color for. We have this thing, which is called quartile 1 and quartile 3. What does this represent? Well, we know the median is the middle of the data. Okay, this represents the exact middle of the data. Well, essentially Q1 is the middle of the first half of the data. So this is the first half of the data. And this represents the middle of that, the Q1. Then we have the second half of the data, and I'm actually going to change this to green. Okay, just going to write over it. Okay, so we have the second half of the data, and the median, again, is this dividing line of the first half and the second half. And Q3, the third quartile, is that middle part of the second half. Okay, so median, exact middle of all the data. Q1 is the middle of just the first half, and then the Q3 is the middle of the third half. Exactly how you would think of it, like a quarter and 50 cents and then 75 cents, exactly the same thing, 25%. So this is like the 25% mark of the data. This is like the 75% mark of the data, and then we have the 50%. What does that mean? Well, a couple of things. One, it means that 25% of the data is right here in this range. It means 75% of the data is in this range. Okay, and the same thing here, 25% of the data right there, 75% of the data right there. And the coolest part is this box represents 50% of all the data. Okay, so 50% of the data lies right there. So that's 50% of the data. Okay, that's just some background information on box plots, so you know what we're talking about and just not mindlessly following along. But now if you're just looking for the answers, now is the part to really pay attention. So the data in the box plot, find the interquartile range. Well, the interquartile range, interquartile means between the quartiles. So between Q3 minus Q1. That is our interquartile range. So we just need to find the value of Q3. Q3 is 8.5. According to this, let me change it to green, just because that's what I wrote on here. 8.5. And then Q1 is 6. So we're just going to subtract those to get our interquartile range. In this case, it's, what's that, 0.5, 2.5 is our IQR. So we're going to type that in. What did I say, 2.5? Yeah. Okay, so what does that interquartile range mean? It means half the data is within 2.5 kilograms of each other, okay? So find the median of the data in the box plot below. Well, I already broke that down in the other video. We know the median is the middle of this box, so right here. That is the median, that line inside that box, so we know it's 6 centimeters. Okay, next question. Find the range of the data in the box plot below. So the range I already kind of talked about a little bit, but I didn't explicitly say it. Here's our max, our furthest right. Here's our min. And the range, how many values how far does the data go? Okay, how many different values does it encompass? In this case, it goes from 9.5 Oh, sorry. Max range is max minus the min. So in this case, our range is 9.5 minus 5. Our max value minus our min value. So that's 4.5. So this data spans $4.5. Okay, that's how far the data goes. It goes from as low as that number and then $4.5 up. What was the bottom number? 5. Okay, so let's check that. And we're on to our last question. Find the interquartile range of the data in the box plot below. We know the interquartile range can be found in this 50% box. Okay, 50% of the data lies in this box. And we know it's between Q3, which is here on the right side of the box always, and Q1, which is on the left side of the box always. Q1. I forgot to make that line. Okay, so we know so Q3 minus Q1 is going to be our interquartile range, IQR. So Q3 in this case is 14 minus 8.5, and that's going to be our IQR. Oh, that's not 8.5, that's 9, isn't it? Almost screwed that up. Whoops. Okay, so 14 minus 9, and we know that's 5. Okay, so 50% of the data is within 5, what are the units? 5 math problems of each other, okay? So 50% of the data, 50% of the math problems assigned were between 9 and 14, so within 5 math problems within each other. Okay, so that's 5, and we'll check it. And that's it. That's all there is to reading box plots. It's kind of a really useful way to display data. You'll see that a lot, especially in higher level statistics works. Thanks for watching this video. Look forward to seeing you next time right here on Wes Explains Best.